Massachusetts, the electrical code mandates ground fault circuit interrupter, or GFCI, protection for sump pumps. Specifically, according to Massachusetts Electrical Code 210.8 AN, all 125-volt single-phase 15 and 20 amp receptacles installed in bathrooms must have GFCI protection for personnel. Furthermore, 422.10 B2 states that sump pumps shall be provided with a cord and plug connected to a receptacle outlet having ground fault circuit interrupter protection. An exception to this rule exists for sump pumps that are part of a fire pump system. Therefore, most sewer ejection pumps in residential finished basements require wiring to a GFCI circuit. For pumps with a piggyback cord setup, the GFCI protection can be achieved by installing a GFCI wall receptacle or by using a GFCI cord. The purpose of a GFCI is to protect people from electrical shock. It constantly monitors the current flowing in a circuit. If it detects that current is leaking to ground, which could happen if someone touches a live wire or a faulty appliance, it quickly shuts off the power. This happens much faster than a regular circuit breaker can react, making it very effective at preventing serious injury or death. In the context of a sump pump, which is often located in a damp or wet environment, the risk of electrical shock is higher. A GFCI helps mitigate this risk by quickly cutting off power if a fault occurs. Several methods exist to provide GFCI protection to a sump pump. Firstly, you can replace the existing standard receptacle with a GFCI receptacle. These receptacles have a test and reset button on the front and are designed to trip if they detect a ground fault. Installation typically involves disconnecting the power at the circuit breaker, removing the old receptacle, connecting the wires to the new GFCI receptacle following the instructions provided, and then re-energizing the circuit. It's important to ensure that the GFCI receptacle is properly grounded. Secondly, using a GFCI protected extension cord is another option. These cords have a GFCI device built into the cord itself. You simply plug the sump pump into the GFCI cord and then plug the cord into a standard receptacle. This method is convenient, especially if you don't want to replace the existing receptacle. However, ensure that the GFCI extension cord is rated for outdoor use and is suitable for the amperage draw of the sump pump. Thirdly, the circuit breaker in the electrical panel can be replaced with a GFCI circuit breaker. This provides GFCI protection for the entire circuit, not just the receptacle. Installation requires working inside the electrical panel, which can be dangerous, so it's best to hire a qualified electrician for this task. A GFCI circuit breaker will trip if it detects a ground fault anywhere in the circuit. When selecting a GFCI device, it's important to consider the amperage rating of the sump pump. The GFCI device should be rated for at least the same amperage as the sump pump. Also, ensure that the GFCI device is suitable for the environment in which it will be used. For example, if the sump pump is located in a damp basement, use a GFCI device that is rated for wet locations. Regular testing of the GFCI device is crucial to ensure it's functioning properly. Most GFCI receptacles and circuit breakers have a test button. Pressing this button should cause the GFCI to trip. If the GFCI doesn't trip when the test button is pressed, it may be faulty and should be replaced. The NEC, or National Electrical Code, provides comprehensive guidelines for electrical installations. While the NEC itself is not law, it is widely adopted by states and municipalities as the basis for their electrical codes. The Massachusetts Electrical Code is based on the NEC, but it may have additional requirements or amendments specific to the state. Therefore, it's crucial to consult the Massachusetts Electrical Code and local regulations to ensure compliance. Licensed electricians undergo extensive training and are knowledgeable about electrical codes and safe wiring practices. Hiring a qualified electrician to install or inspect the wiring for a sump pump can help ensure that the installation is safe and compliant with all applicable codes. This can also help prevent electrical hazards and ensure the reliable operation of the sump pump. When dealing with electricity, safety should always be the top priority. If you are not comfortable working with electricity, or if you are unsure about any aspect of the installation, it's best to consult a qualified electrician. Incorrect wiring can lead to electrical shock, fire, and other hazards. The Massachusetts Electrical Code mandates GFCI protection for sump pumps to enhance electrical safety in residential environments. Understanding and complying with these regulations is essential for protecting yourself and your family from potential electrical hazards. Whether you choose to install a GFCI receptacle, use a GFCI extension cord, or install a GFCI circuit breaker, make sure the installation is done correctly and that the GFCI device is regularly tested. Always prioritize safety and consult a qualified electrician if you have any doubts. In addition to the specific requirements for GFCI protection, there are other electrical safety considerations to keep in mind when wiring a sump pump. Firstly, ensure that the wiring is properly sized for the amperage draw of the sump pump. Using undersized wiring can cause overheating and potentially lead to a fire. Consult the NEC or qualified electrician to determine the appropriate wire size for the circuit. Secondly, use appropriate wiring methods for the location. In a damp basement, use moisture-resistant cable such as Type UF cable. Secure the wiring properly to prevent it from becoming damaged. Thirdly, make sure the sump pump is properly grounded. Grounding provides a path for fault current to flow back to the electrical panel, which helps protect against electrical shock. Connect the grounding wire from the sump pump to the grounding terminal in the receptacle or electrical panel. Fourthly, protect the wiring from physical damage. Run the wiring through conduit or use other protective measures to prevent it from being damaged by tools, equipment, or other objects. Damaged wiring can create a safety hazard. Fifthly, avoid using extension cords as a permanent wiring solution. Extension cords are intended for temporary use only. If you need to run power to a sump pump on a permanent basis, install a new receptacle. Sixthly, label the circuit breaker that supplies power to the sump pump. This will make it easier to identify the circuit breaker in the event of a problem. Seventhly, consider installing a backup power source for the sump pump. During a power outage, a sump pump may not be able to operate, which can lead to flooding. A backup generator or battery backup system can provide power to the sump pump during a power outage. In conclusion, wiring a sump pump in accordance with the Massachusetts Electrical Code and following safe wiring practices is essential for protecting against electrical hazards and ensuring the reliable operation of the pump. GFCI protection is a critical safety measure that can help prevent electrical shock. Regular testing and maintenance of the electrical system can help identify and correct potential problems before they become a safety hazard. When it comes to electrical work, it's always best to err on the side of caution and consult a qualified electrician if you have any doubts. The Massachusetts Electrical Code is based on the National Electrical Code, with amendments specific to Massachusetts. It's crucial to stay updated with the latest version of the code to ensure compliance. Changes to the code can occur periodically, so it's important to review the code regularly. The Massachusetts Board of State Examiners of Electricians is responsible for licensing electricians in Massachusetts. To become a licensed electrician, individuals must meet certain requirements, including completing an apprenticeship and passing an examination. Licensed electricians are required to continue their education to stay up to date with changes to the electrical code and best practices. When hiring an electrician, verify that they are licensed and insured. This will help ensure that the work is done safely and to code. Ask the electrician for references and check their online reviews. A reputable electrician will be happy to provide references and answer any questions you have. In addition to GFCI protection, consider other safety devices such as arc fault circuit interrupters or FSIs. FSIs are designed to protect against fires caused by arcing faults. They can detect arcing faults before they start a fire and shut off the power to the circuit. FSIs are often required in bedrooms and other areas of the home. Surge protectors can help protect electronic equipment from damage caused by power surges. Power surges can be caused by lightning strikes, utility switching, or other events. Surge protectors can help absorb the excess voltage and prevent it from damaging sensitive electronic equipment. Inspect the electrical system regularly for any signs of damage or wear. Look for cracked or frayed wiring, loose connections, and other potential problems. If you find any problems, have them repaired by a qualified electrician. Never attempt to repair electrical equipment or wiring if you are not qualified to do so. The Massachusetts Electrical Code also includes requirements for grounding and bonding of electrical systems. Grounding and bonding help provide a path for fault current to flow back to the electrical panel, which helps protect against electrical shock. Ensure that all electrical equipment and wiring is properly grounded and bonded. Use only approved electrical equipment and materials. Look for the UL listing mark or other recognized testing laboratory mark on electrical equipment and materials. Approved equipment and materials have been tested to meet safety standards. Avoid using counterfeit or substandard electrical equipment and materials. These products may not meet safety standards and could pose a safety hazard. When working with electricity, always follow lockout/tagout procedures. Lockout/tagout procedures help prevent accidental energization of electrical equipment while it is being worked on. To energize the circuit, lock out the circuit breaker and tag it to indicate that the circuit is being worked on. Only qualified personnel should perform electrical work. Electrical work can be dangerous, and it should only be performed by people who are trained and qualified to do so. If you are not qualified to perform electrical work, hire a qualified electrician. The Massachusetts Electrical Code is a complex and comprehensive set of regulations. It is important to understand and comply with the code to ensure electrical safety. Consult the Massachusetts Electrical Code and local regulations for specific requirements.